Hi, this is Merlin. Today I'm just gonna tackle what I learned today. Today the main topic is the variable in assembly. Um, why we should learn about some kind of assembly and what is variable inside assembly. Assembly is just such a program language into really low level. When we had when we had some kind of like low level, like really minimal CPU like 1980 or 1970 or even before that, there's no kind of like modern program language like JavaScript, Rust, or Python. There's only assembly of it. So our foundation of our program language is actually assembly, and this assembly is really is hard to understand because it is um, heavily related to the computer architecture, and especially the CPU thing. So to understand how to use assembly, you have to understand about the computer architecture. Example x86. In the x86, the CPU processor, um, just a processor, right? And inside the processor, there's a register. The register is just the storage of the processor, and there's gonna be general purpose of the register and special purpose register. And the reason why we split into those kind of register is because if you're trying to use C or JavaScript, the operating system handles or the necessary thing to do stuff, to make some stuff. For example, like pointers, reference are usually handled by the operating system. But if it is really low level without operating system, like x86, there's no kind of pointer or those kind of thing. So you have to really track all of it. Example, you um example const name equals to Merlin. That's my name, and you somehow um, call a functions that receives the name. Wait, call name. Let's say call name. So you're just gonna call name Merlin name. Um, in the high level language, you don't have to think about like so deeply because that's working. But if you split this into assembly, even this allocation is handled by the register. So this is kind of the register. Why there's kind of reason why we split into general purpose of the register and special purpose of the register. Um, the special purpose of the register is the like mostly CPU do the really core thing. Example, the fetching next instructions requires some kind of register value, and it doesn't use really the general purpose of the register. It uses special purpose of the register. So the like program counter instruction pointer register is also known as special purpose of the register. But like some kind of like storing as a like temporary, we use general purpose of the register. It's just really simple. If it is const name Merlin, so you just like move ax let's say eax Merlin. So those kind of thing is really similar to this kind of stuff. I know there's a huge differences, but I'm just trying to simplify this kind of stuff. So the thing we can learn from this kind of stuff is the our modern programming language and our current like framework or library is already kind of abstraction of the assembly. Everything is just like abstractions, because the the handling example like even the function calls in the like assembly is requires it doesn't put the argument of it. It has to track um, the the variable of it. Sorry, the register of it, because we just put the Merlin on the register, right? But we can't use same register because it has to be because this the register that can be the origin register can be changed. So you have to create the new register. You have to create the other register, and you copy origin register value to the new register value. And after making those kind of stuff, changing to value in the new register, you put it back into original register, and that is really how it goes. And you really have to know this. This everything is really abstraction. Even the pointer is abstractions. Um, and so from this we can learn stuff. In the JavaScript or other program language, there is an execution context. When you call the functions and the hoisting or these functions, if it doesn't if it gets arguments, it doesn't modify the original one. It makes the new copy of inside their internal execution context, and it manipulates the code. Even though it manipulates the code, it doesn't rewrite this kind of logic in here. That is, and that's kind of really easy. But in the if you look at the x86, it's just basically the making some kind of modifying some kind of new register and push and renew back again. So 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 I think that's kind of important. So what do you mean that's kind of important? Just like assembly in x86, we thought it is really hard. It is really over engineering stuff. I know it's over engineering, but to do this kind of stuff, you're able to understand how does it work in the under the hood. The program language is just the human made. Is there's of course it's gonna be hard, but everything is human made. That means that yours can make, but there's gonna be like take some time, but everything is made. The even though operating system looks so hard, but if you know basic about this kind of using assembly, I believe you can make operating system. So this is it. Have a nice day. See you next time. Bye bye.